Hello, Algebra 2 CP students. Hopefully you're having a great day so far. Today, I'd like to continue our discussion of simplifying radicals, focusing specifically on negative square roots. And I know what you might be thinking, negative square roots? How can you even take the square root of a negative number? Good question. All will be answered today. All right. Notice I have my perfect square chart here. Always a good thing to have by your side to keep track of our list of perfect squares. All right. Always useful when we're going to simplify radicals. Speaking of which, as a little quick do now, you should have no problem if you watched the video yesterday and tried the practice problems or attended live class yesterday if you were in the other group. You should have no problem simplifying something like the square root of 28. What we do, just to recap the process, is we look and see what the biggest perfect square factor is that fits into 28. What's 28's largest perfect square factor? It happens to be 4 in this particular case, because we can break down the square root of 28 to be the square root of 4 times the square root of 7, because 4 times 7 is 28. And the square root of 4 is 2, so I can rewrite the square root of 28 as 2 radical 7. Right? So hopefully no problem with that. We also saw some problems the other day where we had multiple terms that once we simplified them, we were able to combine them together. Those were our transformer problems, if you remember. But what if I'm faced with this? The square root of negative 28. Well, shucks, right? Shucks. There's really no way to take the square root of a negative number. Think about it. What's the square root of negative 4? Is it negative 2? Well, no. Negative 2 times negative 2 is positive 4. So is it 2? But no, obviously 2 times 2 is 4. And then very quickly you would run out of options in the real numbers, right? You completely run out of options to answer a question like what's the square root of 4? So in order to address this, we being mathematicians, have to introduce this new symbol to represent taking the square root of a negative number. And that symbol is what's known as I. Okay? And I stands for imaginary, because I is an imaginary number. And you might be like, are you serious right now? Imaginary numbers? Oh, I'm serious. Imaginary numbers. I represents the square root of negative 1. Okay? I is what's called an imaginary number, and it represents the square root of negative 1. Such that, and this is done such that if I encounter a negative square root, I don't have to stop and give up and just not work with it at all. I can pull out that negative component, call that negative component I, and then just continue to work with the rest of my problem. Okay? So one thing that you absolutely need to know, I don't know what you do in your notes to make something like this stand out. Put a box, a cloud, a highlight, an underline, a star, whatever you want to put next to it to make it stand out. Make sure you do. I is the square root of negative 1. Okay? So if I'm faced with, and we're going to talk a whole lot more about I going forward, by the way, like a whole lot more. So next week, be prepared. We're really going to delve into this concept of imaginary numbers and I. But for now, understand that I is the square root of negative 1. So if I'm faced with this negative square root here, we don't have to panic and freak out. All we understand is, ooh, I can pull out that imaginary component. Okay, I can pop out the I, is what I like to say. Okay, we're going to pull out that imaginary component and split up the square root of negative 28 into the square root of negative 1 times the square root of 28. Well, we just defined over here that we're going to use this symbol called I to represent the square root of negative 1. So I'm going to say, well, the square root of negative 1 is just, we call it I, like that. And now I just have a regular old radical problem, the same as I did over here. Breaking down the square root of 28 is the square root of 4 times the square root of 7. So the square root of 4 is 2, so I have I times 2 times the square root of 7. And the way that this is typically written when you write something like this is you can say it's 2I square root of 7. Typically, it's the real number, 2, then this I part, then the rad. Okay? You can also, if you choose to, write it as 2 square root of 7I. That is how you might see it in a complex analysis, like college level or graduate school level type of class. But for our purposes, we'll keep it as 2I, all of the stuff not inside the radical in front, and then the radical after. 2I rad 7. Okay? So if you notice, breaking down something like the square root of 28 is the same as breaking down the square root of negative 28. The difference is you end up with this component of I, representing the square root of negative 1. Okay? Very important though. And I stands for the fact that it's an imaginary number. So really, this number doesn't exist. Like, it's not a number that I can point to on a number line. I can't have 2I square root of 7 items in front of me. But conceptually, instead of just giving up with this, we'd say, well, if there were a way to take the square root of negative 1, this would be the result. Okay? And the benefit of doing that is sometimes in some problems that you may see, the imaginary components, those i's, will cancel out. Not in any of these, but in general, you may see that in the future. And you actually end up with real number answers, which is really, really cool. And it allows us to tackle more problems than we would normally be able to. Because think about it. Normally, we would look at that and just give up. But we can work with that to say it would be 2 times the square root of negative 1, whatever that happened to be, if that existed in real numbers, times the square root of 7. In short, negative square root, we put an I. that's the bottom line, what you need to know. All right? So let's take a look at a couple examples that incorporate that imaginary component of I when simplifying these square roots. Ready? Let's take a look at 3 times the square root of negative 32. All right? Well, right off the bat, when I see it, first things first, I'd say, ooh, square root of a negative, let's pull out the I. Okay? The I comes out. I should say the square root of negative 1. Sorry. I skipped a step there. It's times the square root of 32. Do it one step at a time. Right? We can break down the square root of negative 32 to be the square root of negative 1 times the square root of 32. What's the square root of negative 1? Well, we just defined that that's going to be represented by I. And I usually put a little curly tail at the end of my I, by the way, just so it differentiates from a 1. But you don't have to do that if you don't want to. Times, now we can break down the square root of 32 into the square root of 16 and the square root of 2. 16 is the largest perfect square factor of 32. Notice you could break it down using 4 and 8, but then you'd have to break down 8 again into 4 and 2. So it's just less work to pick the largest. Now watch as everything carries down. I have 3 times I still sitting there, times the square root of 16 is 4, times the square root of 2. And we're just going to stick all of these together. 3 times 4 is 12, I square root of 2. And so that is how we would represent something like that. Okay, in simplest radical form. That's what this is referred to, by the way. I don't think I mentioned that in the last video. This is referred to as simplest radical form. Okay, next one. Negative 1/2 times the square root of negative 40. Okay. You're probably noticing already that these are really the same as if it was the square root of positive 40, just now there's that extra I step in there. And that's absolutely true. Okay? One thing I want to point out with this problem is make sure that you do not say, ooh, negative times negative is going to make everything positive. Definitely not the case. This negative is inside the square root. This negative is outside the square root. We can't, those two worlds don't mix with each other just because they feel like it. I'm going to have my negative 1/2 over here. I have the square root of negative 40, negative square root. What am I going to do? I'm going to pull out that I. I'm going to pop out the I. Square root of negative 1 times the square root of 40. Because negative 1 times 40 would make the square root of negative 40. The square root of negative 1 we define to be I. So I'd say that this is negative 1/2 times I times. Now how can we break down the square root of 40? What's the biggest perfect square factor that goes into 40? It's 4 times the square root of 10. The square root of 4 is 2, so I get negative 1/2 times I times 2, the square root of 4, times the square root of 10. And then we just clean things up here. Negative 1/2 times 2 is negative 1. I square root of 10. You can certainly write the negative 1 if you so desire, or you can just write the negative sign like that. Alrighty? So notice it really is the same as what we've been doing it before. It's just introducing this imaginary component of I adds that extra simplifying step where we have to pop out that I. All right. Let me show you a couple examples like the problems we ended up doing last time, adding and subtracting multiple terms together, except this time we're going to have terms with i's in them. Ready? Should be a good review too. How about negative 5 times the square root of negative 24 plus 2 times the square root of negative 54. All right. What I would do here is, again, I'd immediately notice negative square roots, got to pop out those i's. All right, I got negative 5 times. Got to pop out the I. We got the square root of negative 1 times the square root of 24. And I'll do the same over here. Square root of negative 1, square root of 54. Notice I'm giving myself a lot of room so I can branch things out clearly here. Okay? Now that I did that, I can go ahead and simplify. I have negative 5 times the square root of negative 1 is I. The square root of 24, what's the biggest perfect square factor? That's 4 times 6. Just to finish up this first term here, I'm going to get negative 5 times I times 2, the square root of 4 is 2, times the square root of 6. And then putting it all together, I have negative 5 times 2 is negative 10, I square root of 6. All right, let's focus on the second term now. I have 2 times the square root of negative 1 times the square root of 54. 2 is going to carry straight down. Square root of negative 1 is I. Square root of 54, what's the biggest perfect square factor that goes into 54? That's 9, because 9 times 6 would make 54. Remember what we said, if you don't know, you could always return to our good friend the calculator and figure that out. Square root of 9 is 3, so I get 2 times I times the square root of, sorry, not square root of 3, times 3. My fault. I'll actually point that out. It's a common mistake a lot of students make. Times the square root of 6. 2 times 3 is 6, so I get 6i square root of 6. And notice this plus sign is just going to carry its way right down here. Okay? I want to point this out. I'm actually glad I slipped up a little bit because a lot of students will say, oh, the square root of 9, and then they'll say square root of 3, and then they'll get confused because now there's 2 square roots, and they'll be like, is this square root of 18? No, 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 no. All we did is we just took the square root. The square root of 9 is 3. Over in this first term, the square root of 4 is 2. Don't write radical 2. That's a common mistake a lot of students make because they just get used to saying radical, radical, radical. When you take the square root, you just get an integer. Take the square root of 9, you just get an integer. All right? And now, like we had yesterday, we have like terms in disguise. Transformers, right? Things that didn't look like terms before, and now we simplify them, and look at that. Like terms that we can combine. We have negative 10i square root of 6's, and then 6 more I square root of 6's, so altogether that's going to make negative 4i square root of 6. Okay? Again, very similar to the problems from the other day. The only difference now is when you have that negative square root, we have to extract that imaginary component. We pull out that I. All right, let's take a look at one more example together. Should be able to fit it over here. We have 1/2 times the square root of negative 120 plus 2 times the square root of negative 50 minus the square root of negative 200. Okay, let's try that problem. I would encourage you to pause the video and try it on your own. But assuming that you've now done that, I'm going to try to do it with you. Okay, last chance. Pause the video if you need to, but it seems like we're okay. So let's break this down. We got 1/2 times. I see a negative square root, so I'm going to pull out that I right away. The square root of negative 1 times the square root of 120. The square root of negative 1, again, we represent as I, so I can write this as 1/2 times I times, now what's the biggest perfect square that goes into 120? You might be thinking, I don't know. Turn to our handy dandy calculator. Let's go down our list of perfect squares. Probably start at like, say 64, maybe 120 divided by 64. Doesn't work. Maybe 120 divided by 49. Rats. 120, can you see it on the screen here? Divided by, just going down my list, maybe 36. Rats. How about 120 divided by 25? Oh, come on. 120 divided by 16? 120 divided by 9? 120 divided by 4? Okay. Whew. We had to go all the way to the end, but we found one. It's 4. All right. So I can break down the square root of 120 to be the square root of 4 times the square root of 30. Right? Because 4 times 30 is 120. So simplifying this now further, I can say, well, we have the square root of 4 is 2, so I get 1/2 times I times 2 times the square root of 30. And putting this together, 1/2 times 2 is 1, so I get I square root of 30. All right, hopefully that was a nice little recap of if we don't know the biggest perfect square, what we can actually do. All right, now we'll go forward for the other terms. Let's see what we can do here. I have a 2. I have a negative square root, so we're going to pull out that I right away. Square root of -1 times square root of 50. The square root of -1 is I, so I get 2 times I times, how can we break down the square root of 50? The square root of 50 is 25 and 2. So here I'm going to get the square root of 25 is 5, so I get 2 times I times 5 times the square root of 2, or plus 10I square root of 2. And last but not least, we have minus. This minus sign is just carrying down. Square root of -200, no number out in front, so we're just going to take that I out right away. The square root of -1 is I. The square root of 200, well, we can break that down to be the square root of 100 times the square root of 2. Square root of 100 is 10, so I get minus 10I square root of 2. Right, because this minus sign is going to carry down 10I square root of 2. And now notice what I have here. I have I square root of 30 plus 10I square root of 2 minus 10I square root of 2. Again, the minus sign just carried straight down. And 10I square root of 2 minus 10I square root of 2 is just going to go away, right? Those terms are going to cancel out. That's 0. Any number subtracted by itself is 0. And so we're just left with I square root of 30. And by the way, I square root of 30 would not have been able to combine with those anyway, so that's that. All right. Pretty cool stuff, right? Pretty cool stuff? Cool. So just as a little quick recap for you, when we're dealing with a negative square root, what we do is we first pull out an I right away. Very first thing. I say, ooh, negative square root, we don't like that. Let's take out that negative component. Remember that the negative component is I, the square root of -1, and then I could just proceed with the rest of my problem as normal. We just have this extra factor of I in here to represent that negative square root. Same thing over here. We saw just pull out that I, and then we treat the square root of 32 just like we did yesterday. Square root of 16, square root of 2, so just carry straight down. We do the same here, treat that just like we did yesterday after we pull out that imaginary component, and the rest carries straight down. If we're dealing with a problem like this where we have multiple terms like we saw yesterday, simplify each one, simplify each one. If those radicals match up and they both have i's, stick them together. Over here we saw kind of a cheeky little problem where these things ended up canceling out at the end here, and we just end up with our first I square root of 30. Kind of cool. I like this problem at the end because it's a good reminder of what to do if I don't know the biggest perfect square. For something like 120, we had to use a little bit of calculator work. And it took a little bit, but we found it right at the end anyway. Okay? And then 10I square root of 2 minus 10I square root of 2 goes away. One last note I want to make about this is just that only imaginary terms can be combined with other imaginary terms. So note, only imaginary terms can be combined with other imaginary terms. So if I have something like 5 rad 2 and I also have 5I rad 2, it might be very tempting to kind of just stick those together and say, oh, well, it's 10I rad 2. But you can't. These are unlike terms because one has an I and one does not. So it just has to stay separated. All right? I don't know if I'll throw a problem like that at you where you have some stuff with I's in it and some stuff without I's. But just so you're aware, that is what you would do. I guess you could factor it if you wanted to, but you'd pretty much just leave it like that. All right? Okay, cool. We'll call it here. A little bit of a shorter video today. Try the practice problems on Google Classroom. I encourage you to do so. I hope you have a fantastic rest of your day. For the rest of the week, we'll practice the ideas that we learned today and yesterday on simplifying radicals and adding and subtracting things with and without i's in them. Like I said, next week we're going to talk a whole lot more about I, and this concept of a negative square root being represented by I does not go away. So don't think it's like this weird thing that's going to pop up and then we're never going to talk about it again. We're talking about it at the beginning of the year for a reason, because it's going to come back pretty much all year. I can't think of when it doesn't show up actually from this point on. So thank you so much for your attention and focus. I hope you have a great rest of your day, and I will see you soon. Take care.